Hey everybody, welcome to another pretty crummy video by Mrs. Buckley, but I'm glad you're here to join me today as we talk about prisms. So actually what we're talking about now is three-dimensional shapes, and a three-dimensional shape is just anything that takes up space. So instead of talking about flat objects like trapezoids and triangles, we're talking about things that actually take up space or that have room for stuff to fit inside. So what's a prism? I'm just going to show you some examples. A prism could be this little matchbox right here. So we call this a rectangular prism because it has a matching top and a bottom that we call bases, and the sides are all rectangles too. We call those the lateral faces. So the lateral faces are also rectangles. So there's a rectangular prism. Now we're going to look at a triangular prism. So this has matching bases, top and bottom, that are triangles. That's why we call it a triangular prism. But strangely enough, just like the rectangular prism that had rectangle sides, my triangular prism also has rectangular sides. So it's kind of weird, but no matter the shape of the base, remember this is our triangular prism, the lateral faces, the sides, are going to be rectangles. Here's another one I made. This is a trapezoidal prism. So it has a top and a bottom. We call those the bases. We have matching. We call these congruent bases actually because they have the exact same shape and size. So I have trapezoids on the top and the bottom. And again, I got rectangles on those lateral surfaces on the sides of the prism. And I got one last one to show you here. This is a pentagonal prism. So I have, let's see, 1, 2, 3, 4, 5 sides. So it's a pentagon, matching top and bottom, pentagonal prism. And again, I just have rectangles along the sides. I could have done a better job making this, couldn't I? But you get the point. So we've got all kinds of prisms. Now, when we are trying to measure the volume of a prism, we're talking about how much stuff fits inside. So for instance, here's a big box of matches. It says on the box that it holds 250 matches. So the volume of this box is actually 250 matches, meaning that if I fill it all the way up, it will hold 250 matches. Here's a bag of pretzels, one of my favorite snacks. And it looks to me that this probably holds about 25 pretzels. So we would say that the volume of this bag is 25 pretzels because that's how much it holds when it's completely full. So obviously in math, we are not going to measure the volume of objects in matches or pretzels. What we measure volume in is cubes. So let's take a look at what I mean here. I'm going to take my box and I'm going to start loading up the cubes in an organized way. I hope it's going to be organized. I guess we're going to find out. So I've got a row of 5 right there to start. I hope you can see that. And I can keep adding cubes until this box is completely filled up. So I'll have a full layer on the bottom, and then I'll just keep stacking the layers up. And the volume of this box would be some number of cubic units, however many cubes it holds when it's completely full. So let's take a look at some pictures. Let's start with these right here. So I'm going to look at this first diagram. I see the number of blocks in this picture as 1, 2, 3, 4, 5, 6, 7, 8, 9. And since there's just this one layer, we say that this is 9 units cubed. We can also read that as 9 cubic units. Let's look at this one over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So I have 20 in this first layer. But can you see that I have another layer behind it? So if I have 20 in the first layer plus 20 in the second layer, that would be a total of 40 units cubed, or 40 cubic units. All right, one more picture. I don't know about you, but I look at that picture and I say, no way am I gonna count that up. So I'm gonna show you a little trick. You're gonna like this better than counting cubes. So what we're gonna do is count the number of cubes along the length here. We're going to count the number of cubes along the width there. And we're gonna count the number of cubes of the height. And I just wanna go ahead and label these. Length, width, and there's not a good place for my H for height, but I'm gonna put it there. So let's see what we've got. 1, 2, 3, 4, 5, 6, 7. So my length equals 7. Then I've got 1, 2, 3, 4. So my width is 4. And then my height, 1, 2, 3, 4, 5, 6. Okay, 7 again. So the height, I'm gonna write it up here, is 7. So what do we do with this? We have a formula, and I'll show you about it in just a second. The formula is volume equals length times width times height. So if my length is 7, I got that from here, and my width is 4, that guy's gonna go in there, and my height is also 7, I can multiply all three of those numbers together, and you of course are welcome to use a calculator on this. So I've got 7 times 4 times 7, and I have 196 units cubed, or we can read that as cubic units. Okay, so let's start with some diagrams now. And I won't be asking you to count cubes anymore, thank goodness. We're just going to be using the formula. So let's take a look at the steps that we need to use to be careful formula users. So the first thing you're going to be doing is copying the shape and the measurements. You're going to label the length, the width, and the height. Then you're going to copy down the formula. You will fill in what you know, and then you will calculate the answer with a unit. So how do you draw a rectangular prism? It's actually pretty simple. So to start, just draw one rectangle, then draw another rectangle that overlaps, and then you just want to connect those corresponding parts. So pretty simple. So you are copying this first shape. This is sample number 1. This will be part of the work that you turn in to me. So let's look back at our steps. So we copy the shape and the measurements. Got it. I'm going to label now the length, the width, and the height. So here's my length, here's my width, and here's my height. So we've done step 1, we've done step 2. Now we're ready to copy the formula. And remember, you're writing everything that I am writing, because I know you want full credit on this assignment, and I want to give it to you. So the volume is equal to my length, which is 3, my width, which is 4, and my height, which is 2. You've got your calculator. You are multiplying all of those numbers together, and 3 times 4 times 2 is 24. We're measuring in meters, and what we mean is how many cubes that are a meter on each side. So the volume of this would be 24 meters cubed. All right, let's look at the next one. So we're going to copy the shape and the measurements. Step 1, and you can go ahead and do that on your paper. Please label it sample number 2. We're going to label the length, the width, and the height. And honestly, if you're saying to yourself, how do I know which is the length and the width? It doesn't matter. It really doesn't. So we're ready to copy our formula. Volume equals length times width times height. We're ready to fill in what we know. This is step 4. Volume equals my length of 8 times my width of 5 times my height of 20. I am ready to multiply those numbers. 8 times 5 times 20 is 800. And since we're talking about centimeters here, we're talking about how many cubes that are a centimeter on each side will fit in there. So we're talking about 800 centimeters cubed, or cubic centimeters. All right, here we go. Last one on this page. Get our steps there. So sample number 3, you're writing that on your paper. Step number 1, you're copying the shape and the measurements. Step number 2, we're labeling the length, the width, and the height. Now I'm ready to copy my formula. So volume equals length times width times height. Volume equals my length of 11 times my width of 2 times my height of 9. When I multiply all those numbers together, I will get 198 feet cubed. Or you can also read that as 198 cubic feet. Okay, so that's the end of the samples. So everything on your paper should look exactly like this. And if you need to pause the video and fill in anything on your work, go right ahead, and I'm going to give you the independent work in just a sec. Okay, so today I've got 3 samples of independent work that I'd like you to work on. I want you to remember that these are the steps that we are following for every single one of these problems. It might be helpful to you to start out just by copying down the 3 shapes and then working through the process. Make sure that each of your examples looks exactly like the models that we did previously in the video. I think this is pretty straightforward. I bet you're going to do a wonderful job with this. I'll look forward to seeing your great work, and I'll talk to you soon. Bye-bye.